In today's class, we're going to talk about functions, preparing you for quiz 2. Okay, like we always do, if you have a question, you use the income messages, or you can unmute your mic and you speak. The 100% that you got, some of you in the previous quiz, that was a heads up. Congratulations. Want another one. Okay, so in today's session, we're going to talk about, I'll not take it lightly that you guys understood the basics. So we're going to start from the basics until to everything that you are supposed to know, preparing you for your quiz 2. So we're going to talk about relations. Okay, we're going to talk about, the inverse of a function. We're going to talk about how you show that a function is a one-to-one. We're going to talk about the even, the odd, the neither. We're going to talk about, composite functions. We're going to talk about the domain, in case most of you maybe never understood the domains and the ranges of all types of functions. We're going to talk about, quadratic functions, rational functions, radical functions, modulus functions, piecewise functions, even polynomials. I think when you do these, you'll be good to go. Okay, so without wasting much of the time, so let's start. Relations. Okay, so the basics of functions, the basics really matter. I will not take it lightly, like I've said. Okay, so when talking about relations, we know that a relation is just a mathematical relationship between an input and an output. The input in this case, we're talking about the x values. The output in that case, we're talking about the y values. Okay, so let's say if you have a scenario where you have your input values, you've got A, you've got B, you've got C, and you've got D. Your output values, let's say this is giving you 8, 9, and let me say 11. Okay, then the mapping between these is your A is going to your 8, let's say B is also going to 8, C is going to 9, and D is going to, let me say, 11, like that. Okay, so what kind of a relation is this one? So you know that this one is called an onto function. Okay, an onto function is also called the what? A subjective function. Okay, then this is also called a many to one, because you've got two input values that are giving you one output value, like that. Okay, so this is a function. I can give an example in case, let me say you've got x and you've got y. You can have two x values, maybe let me say -1 and 1. Let me say 2 and -2. Okay, -1 squared, it will give you a 1. 1 squared will also give you a 1. So two x values or two input values are giving you one output value. That's the scenario that is here, like that. Okay, so it's called the many to one. The square root of 2 or -2, it will give you a 4. So both of them, they are going to 4. Okay, so this is an onto function. Very, very important for you to know. Then another thing that you need to understand here is another thing that you need to understand, let's say if x, you've got y, you've got 1, you've got 2, you've got 3, then your output values, you've got A, you've got B, you've got C. These ones are relating like that. This is the mapping between these is your 1 is going to A, your 2 is going to B, your 3 is going to C. Okay, so what do you call this kind of a relation? Anyone? Okay, it's called a one-to-one function. You can also call it an injective function, like that. Very, very important for you to know. Now this arrangement brings me to something that you should also know. The x values, like we've said, these ones is called, they are called the domain. In this case, where all the y values are related to some x value, this one will be called the range. Okay, very important for you to know. Okay, now let's talk about relations which are not functions. Very important, you have to know relations which are not functions. Okay, let's say you've got 1, 2 and 3. I've got letters, let's say A, B and C, or let me also put D like that. So your 1 is mapping with A, your 2 is mapping with B, your 3 is mapping to C, and it's also mapping to D. Okay, now this kind of a relation is called a one to many. Okay, so you're able to see that one input value is giving you 2 output values. So this is called the one to many. Now I must make mention that this is not a function. Why? Because you've got one output value that is giving you 2. You've got one input value that is giving you 2 output values. So this is not a function. Another scenario that you can have is, let me say you've got A, you've got B, C, D, you've got 1, let me say 5 and 6. Okay, then the mapping between these ones is maybe A is going to 1, let's say C is going to 5 and D is going to 6. So this will also not be a function. Okay, it will not be a function because one of your input values is not related to any of the output values. So this is not a function. Okay, then other thing that you need to understand about relations is when you combine an injective function. An injective function is the one that we said is a one-to-one function, plus a subjective function, okay, or an onto function. This will give you what we call a bijective function. Okay, now a bijective function is just all the x values are related to some only one x value is related to some one y value, like that. That's the relationship that we're talking about. You will see how imperative that is for you to know. Okay, so these are some of the things that you need to understand about injective and bijective and relations. Now let's talk about inverse functions. Very, very important. I won't spend a lot of time here. When you've got an inverse function, it's a function that reverses the output. Okay, you cannot find the function, you cannot find the inverse of a function that is not bijective. Okay, for example, a quadratic function, you have to make sure that you restrict the domain. Okay, that is very important for you to know. Okay, so let me say you're given let's say you're given f of x is equals to 5x plus 1. Okay, so let's say they've asked you to find f of 1. So you're going to say f of 1 will be equals to, wherever there is x, you're going to replace it by 1. So you have a scenario where 5 plus 1, which will give us a 6. So now what this entails is that you are trying to find a function. If you plug in 6, you get the input of 1. Okay, that's why I'm saying it is a function that reverses the output. Okay, very, very important. So you have to know the inverse of a function. So in this case, you're just going to make y or f of x a subject to the formula, then you proceed like that. Very, very important for you to know. So, and I must make mention something here, that you're going to use the inverse of a function to find mostly the range, because we've said it reverses the output. So if it reverses the output, it will be called the range. So as we be talking about the range, you understand that one further. Very, very important for you to know. Okay, now you also have to know how to show whether a function is one-to-one. So if you given function, let me say the function one function and another function. So in this case, your f of a should be equals to f of b, okay, or your a should be equals to b. Let's say you're given a scenario where you're trying to find to show if this is a one-to-one. So what are you going to do? You are going to say your f of a should be equals to your f of b, okay? So f of a in this case, let me say this is x. So wherever there is a, you're going to be replacing by a, okay? So you're going to say 4a minus 3 is equals to, on the other side, wherever there is x, you're going to be replacing by b. So you're going to say 4b minus 3, okay? Then to solve this further, what are you going to do? You know that your negative 3 and your negative 3 will cancel, or your negative 3 when it goes on the other side, it becomes a positive, and a positive and a minus, they'll just give you a 0. So you remain with 4a is equals to 4b. Your 4 and your 4 can divide, so therefore you're going to end with a is equals to b. In this case, you've shown that a function is one-to-one because a is equals to b. That is very important for you to know. Okay. Now let's talk about even, odd, and neither functions. Okay. Provided you never understood this one. Okay. Let's start with the even function. Now, when we're talking about an even function, is a function that is unchanged when reflected above the y-axis. Okay, so this function is in the form of f of x is equals to x squared. Okay, it's like a quadratic. So let me give a scenario where, let's say this is your graph. Okay, this is your graph. Let me put it small. This is your graph like that. Then let's say, what are you trying to find? Let's say your values, in this case you've got which values can we pick? Okay, let's say you've got 2 points. You've got this is negative 3, this is 3. Okay, then let's say this is 9. Okay, then they're giving you a point there, giving you a point. Then this graph is starting at 0, 0. So it means that this graph will go in this to start from here, or to start at the turning point and going like that. Okay, now if you are going to put the points here, this will be to be negative 3, 9. On the other side, this will be what? It will be 3, 9. Okay, now you realize that if you square 3, if we put a value of x, if we say negative 3 squared, it will give us a 9, right? A value of a 9 there. Very, very important. Then if we also do positive 3 squared, it will also give us a 9. Now what can you notice? The value of y is not changing. Okay, the value of x has changed, yes, but the value of y is not changing at any point. So this is what we call an even function. The other thing, look at, there's a square here. Okay, 2 is an even number, so you have to also understand that. Now how are you going to find an inverse function? You have to know this equation. It's a must know. Okay, if we say f of negative x, f of negative x should be equals to f of x. Okay, what this means is that whether you put a negative or a positive, you still have the same value of y. Okay, very, very important for you to know. Then let's talk about an odd function. Okay, an odd function is a function that is rotated about 180 degrees. Okay, since it's rotated at about 180 degrees, so it will be f of x is equals to x to the power 3. Okay, very, very important for you to know. So if I'm going to draw my diagram, if I'm going to show this by by diagram, just for illustrations, let's say this is our x or y plane. Okay, let's say that is our x or y plane. Okay, let's say we've got so the way it's going to move is, let's say this is your your graph like that. Now you're going to rotate this by 180 degrees. So from its position it will be rotated like that, right? Okay, then again it will be rotated like that. Therefore, how your odd function is going to be to move from the where it is and it to remain like that. Now, one thing that you should understand is that in this region, your value of x and the value of y are negative. X is negative, y is also negative. Therefore, for you to find your odd function, you are going to say f of negative x is equals to negative f of x. Why negative f of x? Because the value of y here is negative. Okay, very, very important. So even in the other equation, f of negative x, we're getting f of x, we're getting a positive value of y. Okay, very, very important. So this is what you are supposed to know on even and the odd functions. Okay, then if a function doesn't satisfy either of the two, okay, it is called a neither function. Very, very important. Then let me try to solve an example just to put it into context. Let's say you have a scenario where you're given, let's say to find, let's say f of x is equals to 2x squared minus 3, and another scenario is f of x is equals to 2x to the power 3 minus 3x. Okay, so how are you going to do that? Now, even without solving, just even before you start solving, your powers of x can give you a clue about what your final answer will be. That's a goodness. Okay, so in other that 2 is an even number, then even here there's a 0. Okay, if you say x to the power 0, that is just 1 multiplied by 3 is 3. Okay, so you've got 2 and 0, those are the powers of x. So 2 and 0 are even numbers. So when you solve this one, it's going to be even. Okay, but you have to solve it. Okay, then on the contrary, you have this one has a power of 3 and this one has a power of 1. Now 1 and 3, these ones are odd numbers. Okay, very, very important. Odd numbers are those numbers when you divide by a 2, they will leave a remainder of 1. Even numbers are those numbers which are divisible by 2. Okay, very, very important for you to know. So how are we going to solve the first one? So we're going to say f of negative x is equals to f of x. So we're going to say that or the other way around. Let me put f of x is equals to f of negative x. It's just the same. Okay, so what I'm going to do, wherever there is x, you're going to replace it by negative x. Okay, so to be like that. Then when you solve, you know that negative x squared, that's just x squared. Okay, so you have 2x minus 3. Now you're able to see that this is equals to f of x. Okay, so because it's like that, this is an even function. Okay, then if we're solving the second one, we're going to say f of f of negative x is equals to negative f of x, just to show that it's an odd function. Okay, so what I'm going to do, what you're going to do is you're going to say 2 negative x to the power 3 minus 3 negative x. Okay, this is going to give you 2. Actually, because there's a negative x to the power 3, that will give you a negative x cubed, right? So you're going to have negative, then x like that. Okay, then your negative 3 and your negative x, what are they going to give you? They're going to give you a positive 3x. Okay, now when you reach here, you're able to see that this is not even. Okay, this is not even. So what are you going to do? You're going to factorize the negative. So you're going to put the negative, then you have 2x, you have minus 3x. This will be your final answer. Now you're able to see that this is equals to that. Okay, so this is an odd function. So very important for you to know. Okay, then you also have to understand what we call composite functions. Now a composite function is just a function of another function. Okay, let's say you're given f of x is equals to 2x plus 1. Let's say you're given g of x, let's say it's x plus 1. Okay, so you'll be given to find maybe let me say f of g of x, or what we call fog, or you can also be given to find g, let's say g of or golf. Okay, or even if they want, they put numbers like that. So how do you do these ones? So just make sure that the function that they've given you first is the one that you write. Then you're going to be replacing by x by the function that follows. Okay, in this case g of x. Let's solve the first one. So how are we going to do that? Okay, how are we going to do that? So you're going to say your f of g of x will just be equals to, we're going to say 2, because that's the function that's f of x. So wherever there's x, we're going to be replacing by g of x. So our g of x is x plus 1, so there's a plus 1 at the end. So you solve this, so it will be 2x plus 2 plus 1. Okay, that will just give us 2x plus a 3, like that. So this will be your answer. Then for the next one, what just means is that you get the function of g, let's say g of f of x will just be equals to, you write the function wherever there's x, you're going to be placing the function for f of x. So what are you going to do? So because your g of x is x plus 1, so you're going to say 2x plus 1. Okay, that's your x plus 1. So then you solve. So to be just 2x plus a 1 plus 1, that is just a 2. Okay, so this is how you're going to find this composite function. You're just substituting one function into the other one. Very important for you to know. Okay, then the domain and the range. Now when we're talking about the domain, you're talking about you want the values of x that will make the function defined. Okay, I've seen most of you struggle to find the domain for certain functions. Okay, so the domain in this case, don't memorize. No, we're talking about the values of x that will make the function defined. Okay, you want all the values of x, but those ones which will not make the function defined, you have to exclude them. Okay, that's what we're talking about. Now on the domain and the range, you have to know how to find the domain of a linear function. You have to know how to find the domain of a quadratic function. You have to know how to find the domain of a radical function. You have to know how to find the domain of also a rational function. Now this is either way, the domain and the range of both of them. Okay, so like we've said, the domain, these are just the input values, the values of x. Then when you put the values of x in a certain function, they will give you a certain value of y. That value of y is called the range. Okay, so you have to know those ones. Now the way you find the domain and the range differs for different kinds of functions. Okay, let's start with a linear function. Okay, now a linear function, it will just give you a straight line. Let me say this is my graph. Just for this function, maybe just gives you a straight line, like a very straight line like that. Okay, this is a linear function. Another one can just be in any direction. This is a linear function. Just one line, this is a linear function. So it's just a straight line. So every function that is in the form of y is equals to mx plus c will be a linear function. Okay, then let me give an example. If you have, let me say y is equals to 2x plus 1, this is a linear function. Okay, now for the linear functions, what you need to understand about the domain and the range is that all values of x will exist, all values of y will exist. So the domain for the linear function will just be equals to, you know, all real numbers, okay? Or those ones who want to express it in set interval notation, you want all the values of x from negative infinity to positive infinity. Very, very important. Then how do you find the range of a linear function? So the range of a linear function will just be also all real numbers, okay? So again, we're starting from negative infinity to positive infinity. Why? Because every x value will have one y value. Every x value will have one y value. Everything will exist on a line. If I say this is a line, these are the lines. Like if this is the line that we're drawing, everything will exist on this line, okay? So that's what we're talking about. Everything exists. So this is very simple. Then how do you find the domain and the range of the quadratic function? Okay, now quadratic, you know, it's in the a function in the form of, let me say if I say f of x is equals to x squared, okay? Or let me say x squared plus 1 if I want, okay? So that is a quadratic. Now when I'm talking about the domain for a quadratic, there is no x value that you're going to put in this equation that will make the function to be undefined, okay? Whether I put a negative or a positive, it will always be defined, okay? So in this case, the domain for a quadratic, let me call it df, will just be equals to all real numbers as well. What do you want? Values from negative infinity to positive infinity, because there's no x value that you're going to put here that will make the function undefined, okay? Then the range for a quadratic function, how are you going to do it? That's why we talked about the inverse of a function. You have to find the inverse function, okay? The inverse function, okay? So how do you find the inverse function? You make y the subject, you make x the subject to the formula. Like in this case, you're going to say y is equals to x squared plus 1. Then you make x the subject to the formula. So in this case, it will just be x squared, it just be equals to, you know, your y minus 1. So for it to remain with your x, you're going to square root on both sides. Okay, so what are you going to have? You have x is equals to the square root of y minus 1, okay? Now this is what will give you the range of y values, okay? So the range of y values, so the inverse in this case would be f inverse of x will just be equals to, wherever there is y, you're going to replace it by x, okay? So it will be x minus 1, but we're not finding the inverse, okay? But the inverse just helps us to find the range, okay? So in this case, how are you going to do that? So now you realize that it has given you an answer in a root. Now that is a radical, okay? A radical. So now how do you find the inverse? How do you find the, you know, the range in case you're given a radical? So what you don't want in a square root is what? You don't want a negative number, right? Any negative number. Why? Because it will give you complex numbers. You don't want complex numbers. So you're going to set what is in the root. You're going to say y minus 1. This should be greater than or equal to 0, okay? Now greater than or equal to 0. 0 is included because the square root of 0 is just 0, okay? But all numbers that are less than 0 will give you a negative in the root. So the range therefore will be, you're going to say y is greater than or equal to 1. So therefore the range will be, you want all the values, okay? You want all the values of y that are greater than or equal to 1. So that will be your range, okay? Very, very important. Now that we've introduced radical functions, how do you find the range and the domain of a radical function? Okay, now a radical function, okay, don't worry, we're going to talk about these ones one by one, okay? We're just talking about the domain and the range of all of them, Okay, so a radical function is a function that is in a root. Okay, so let me say f of x, your f of x is equals to, let me say a root, the root of 1 minus 2x. Now the root of 1 minus 2x, so how are you going to find the domain and the range? So the domain, in this case, you're going to get what is in the root, because you don't want any x value that will give you, you don't want, when you put an x value, to give you a negative in the root. So you're going to say your 1 minus 2x, this should be greater than or equal to 0. Okay, so you're going to say, in this case, if you're going to solve this one, to be x should be less than or equal to, okay, let me just solve it step by step. So you're going to take the negative 1 to the other side, so you have negative 2x is greater than or equal to, when the one goes to the other side, it becomes a negative. Okay, so now you're dividing by negative 2 on both sides, so your x in this case will be less than or equal to half. Okay, why have we changed the sign? Because when you are dealing with inequalities, when you are dividing by a negative number, the inequality changes the direction. Okay, so what this means is that you want all the values of x that are less than or equal to half. Okay, simple like that. Very, very important for you to know. Okay, so that's what you're going to do. Then what other thing? Then for you to find the range, you're going to come up with a table of values. Okay, in that table of values, because this is an inequality, you're going to test the inequality where it's positive and where it's negative. Then you don't want negative values in the thing, so the range will just be all the values that are in the positive region, like that. Then for rational functions, okay, we're talking about a function that is a fraction. Okay, let me say f of x is equals to, let me say 4 minus 2, maybe minus x, like that. Okay, so how are you going to find the domain and the range for a radical function? So what you're going to do is you're going to make you have to make sure that the denominator, in this case, you don't want a 0, because 0 divided into any number, it is undefined. So you're going to say your 2 minus x, this should not be equals to 0. Okay, so therefore your x, in this case a negative x, should not be equals to negative 2. This simplifies to x should not be equals to 2. Okay, so you want all the values of x, but you just don't want 2. Okay, everything exists except 2. That's what it means. Okay, the range, to find the range, you're going to find the inverse of this function. Okay, the inverse of this function, now this rings a bell. This is just like the way you find for a quadratic, find the inverse of that function. So I'm going to find the inverse. You're going to say f of x, it will be y now. Okay, just to make your work easier. So you're going to say y is equals to 4 over 2 minus x. Then you make x a subject of the formula. So here I can say over 1. So it will be, 4 is equals to 2y minus xy. Okay, I can take the negative x to the xy to the other side, and I take the 4 to the other side. Okay, so what am I going to have? I'm going to have xy is equals to 2y minus 4. Okay, then I'm going to divide by y on both sides. Okay, so when I divide by y, my answer I'm finding, allow me to write here, my answer will be y, to be x is equals to 2y minus 4 over y. So now you get the denominator. You know that in the denominator you're not supposed to have a 0. So in this case, the range will be y should not be equals to 0. Okay, because that's, but let's say if you had the scenario, let me say it was y minus 1. So you don't want again this scenario to be 1. So if I'm going to do that, if it was y minus 1, the way I'm going to solve it, I'm just going to say y minus 1 should not be equals to 0. Okay, so your y in this case should not be equals to a 1. Okay, so this will be the range. So you want all the values of y, but you just don't want a 1, because if I say 1 minus 1, it will give me a 0 in the denominator, hence making the function undefined. Very, very important for you to understand that. Okay, let's talk about another concept, quadratic functions. Okay, quadratic functions are those functions that are in the form of ax squared plus bx plus c, like we've seen. Okay, now after solving a quadratic expression, what you need to understand about quadratic functions, you have to know how to find the roots of quadratic functions. You have to know how to let me say complete the square. You know, you have to be able to solve equations, even sketching these quadratic functions. Okay, now let me make something very clear here. If you are going to solve any quadratic expression, you know that you are getting two answers. Let me say x is equals to 2 or x is equals to 1. Now these ones are called the roots of the quadratic equations. The answers that you find are called the roots. Okay, so because it's x, now which equation gave us these answers? Okay, so I'm going to take it back. I'm going to take these ones back the way they were initially. So I'm going to say x minus 2, and I'm going to say x minus 1 is equals to 0. Okay, now when I solve this, in the end I'm going to have x squared minus 3x, you know, plus 2 is equals to 0. Okay, when I expand that expression, now this is a equation that gave us those roots. Okay, now what if we want to come up with an equation that will account for every general expression if you are given the roots? Okay, in this case you are using letters. Let's say x is equals to alpha and x is equals to beta. Okay, these are Greek letters. Okay, so when you want to use letters, so we're going to do the same. We're going to want to find the equation that gave us those ones. So we're going to say x minus alpha, and you're going to say x minus beta. Okay, this is equals to 0. Okay, when I solve this expression, I'm going to get x squared. The way I'm solving it, x is multiplying by everything in the bracket, and your beta or your alpha is multiplying by everything in the brackets. Okay, so that's why I'm just doing that. Okay, so when you solve that one, you're going to say x squared minus, you know, you're going to get, you know, bx minus alpha x plus alpha beta is equals to 0. Okay, now when I simplify this one, it will be x squared. I'll factorize what is in the middle here. So what am I going to have? I'm going to have minus alpha plus beta. My x will be outside because it's the one that is common, plus alpha beta. Okay, this is equals to 0. Now this will be the general equation that you're going to be using. Okay, so this will be the general equation that you're going to be using for, or you know, the expressions that you're going to be given. Now you're able to see that. Let me write the general equation that we said the form. We said the form is ax squared plus bx plus c is equals to 0. Now if in this expression, if we factor out a, it will be, if we factored out a, how will the expression be? A, it will be x squared plus b over a, there is an x there, plus c over a, like that. Okay, this is equals to 0. Okay, now you are able to see that this expression and this expression, they are no way different. Okay, so because they are no way different, your alpha plus beta, or your negative alpha plus beta has an x, and even this one b over a has an x. So you're going to equate the two. So what are you going to have? You're going to say negative alpha, this is negative alpha plus beta, is equals to, you have b over a. Okay, because both of them have got x and this one has an x, so they are the same. So what are you going to do? You're just going to distribute the negative, or you're going to divide by the negative on both sides. Okay, therefore your alpha plus beta will just be equals to negative b over a. This is another equation that you need to know in your head, okay? In and out. Very, very important for you to know this equation. Okay. Then you're able to see also that your alpha beta is also giving you C over A there at the end. So what does that mean? Alpha plus beta, or alpha multiplied by beta, will just give you C over A. This is another equation that you need to know, okay? So know these 3 equations, then you are good to go. Okay, then let's mention something very critical. Okay, let's say you're given a formula x is equals to, negative b positive or minus the square root of let me say that's one b squared minus 4ac over, let me say, over 2a. Okay, now you know that this is the general quadratic formula. Now, one thing that you should know is that what is in the root here is called the discriminant. Now, what's the function of the discriminant? The discriminant will determine how the equation is going to move, or the behavior of, let me say, what you're going to get. Okay, so whether the function is going to cut, maybe whether you're going to have x-intercepts or y-intercepts. Okay, so that's what I should know. Now here on the discriminant, let me make something clear. Okay, so when your discriminant, that is b squared minus 4ac, that is your discriminant. When this is greater than 0, okay, what this means is that you are going to have 2 distinct to mean different, okay, distinct real roots. Roots, we're talking about the answers that you get after you solve the quadratic expression or equation. Then when your discriminant b squared minus 4ac, when it is equals to 0, okay, in that case what you're going to get, you're just going to have 1 real root, okay, 1 real root. Very, very important. Okay, then another thing that you need to know is that when your discriminant b squared minus 4ac, this is, let's say it is less than 0. When it's less than 0, we're talking about negative numbers, right? And when you have a negative number here in the root, what are you going to have? You are going to have a complex number. The square root of a a negative number is a complex number. So in this case, we're talking about you're going to have two complex roots. Okay, 2 complex roots. Okay, so you have to understand that. Now if in a question they only ask you to find the real roots, if they haven't specified whether it's distinctive real roots or real roots just like that, or 1 real root, so when they are generalizing, so you're going to say your b squared minus 4ac, or your discriminant will just be greater than or equal to 0. What this means, you are just combining these 2 which have real roots in them. Okay, very, very important. So you have to understand that one. Okay, then let me talk about other things that people also need to understand on quadratics. Okay, on the alpha and the beta, okay, if I say a squared plus b squared, this is not equals to a plus b squared. Sometimes people tend to be lazy, so they just do that. Please don't do that, it's wrong. If I say a squared minus b squared, this is not equals to a minus b squared. Please don't make that mistake. Okay, now how do these ones simplify to? So the equations that you are supposed to know: a squared plus b squared. Now what is it going to give you? It's going to give you a plus b, this squared, minus 2ab. Okay, now this is not, you can sort it, but the way it just comes, you just simplify this expression. Okay, it's going to take you back there. So that's what I'm talking about. But I'm not going to solve this because we solved it in the other videos. So you can access all the videos, they are there, okay? Okay, on all the topics that we're talking about today. This is just a recap. So say a squared minus b squared. What is it going to simplify to, okay? Or let me say, okay, another consideration that I can put is what? Let me say a minus b, okay? A minus b squared. This is just a difference of two squares, okay? To just be a minus b, a plus b, okay? Then another consideration that you need to take place to understand is, what if we raise the power to 3? Okay, let me say a cubed plus b cubed. Okay, so you have a plus b. This you also have a squared minus, you know, ab plus b squared. So this is another identity that you need to understand. Then let's raise the power to 4. Okay, let's say a to the power 4 plus b to the power 4. What are we going to have? Get the first expression, a plus b, okay, squared minus 2ab, okay? Now, in the first expression, this is the same as the first expression, okay? So now what do? Wherever there is a letter, square. Wherever there's a letter, you're supposed to square. So what am I going to do? Here there's a letter, I'm going to square. Where there's b, I'm going to square. Where there's a, I'm going to square. Where there's b, I'm going to square. That's how you're going to find to the power, 4 like that. So you have to understand these simple concepts. Very, very important for you to know. Then on quadratic expression, the last concept that we're talking about is very cardinal. How you complete the square and you sketch, okay? So how can I put this one? Maybe in a question, let me say f of x is equals to x squared minus 4, let's say x. Okay, let's say x. So how are you going to solve such equation? So when you're dealing with completing the square, you want your answer to be in the form of a x plus p or any letter, or okay, p, that is just the value of x at that point. This is squared plus a q. Okay, now before I go any further, I must make mention that your p in this case just shows you, because there's a value of x here, right? So it shows you how the x is shifting, okay? How the values of x have shifted to a certain, value. Then your q in this case just shows you the shift in the y. So what are we talking about? We're talking about the turning point, where your graph is going to start from, okay? So the turning point of the graph, the way you're going to find it to be negative p, comma q, okay? Others, they'll just get the same equation. They're just going to say x, for you to find the value of x at the turning point, will be x is equals to negative b over 2a, okay? So in this case, that's how we're going to find the turning point, okay? So so let's solve the one that we have. So how do you solve using completing the square? I'm not going to really solve into it much like that, because there's a video we've talked about these ones. I'm sure you know. So what you're going to do is you're going to factor out in this case our a is just 1, right? So 1, you're going to have x squared, minus 4x, okay? That's just like that. Then what are you going to do? So you're going to have the equation of a linear function. The linear function is just 4x, like that. Find the half of that and square it, okay? So in that case, then the ones with the square, you put them in the same bracket. So what I'm going to have, x squared. Then when I find the half of negative 4, that is just negative 2. Now negative 2, when I square it, so because it's squared, I'm going to put it in the same bracket with the x squared, okay? So I'm going to put it in the same bracket with the x squared. So that is minus 2. These ones will be in the same bracket, okay? Then because I had also minus, like minus 2 squared, that gave me like a minus, 4 like that. So that's how it's going to simplify. And when you simplify this one, the turning point in this case is this value of x, like we've shown here, okay? But now we're saying it is a negative, okay? So the sign will be alternating, okay? So in this case, the turning point for this graph will be 2, negative 4, okay? Your 4 is there, the negative 4 is there. Then what other things are you supposed to know? Other things that you're supposed to know is where the graph is going to cut the x-axis and the y-axis, and that is called the intercept, okay? So at the y-intercept, x is equals to 0, okay? At the x-intercept, y is equals to 0. So what are you going to have? So I get the same equation wherever there is x. If you're going to find the x, let me say you're going to find the y-intercept. Wherever there is x, you're going to be placing by 0, okay? So you're going to realize that it just be 0. So in that case, your y-intercept will be 0, 0, okay? That's where the graph is going to cut the y-axis. Then on the x-axis, wherever there is x, you're going to put f of y or f of x to be y, and so it to be f of x is equals to x squared minus 4x. Where there's f of x, that is y, so you're going to put 0 is equals to x squared minus 4x. So what are you going to do? You factorize, so 0 is equals to, so you're going to say x minus 4, yeah, like that. So what this means is that your x therefore is equals to 0, and your x minus 4 is also equals to 0, so x is equals to 4. So we've got two values, x is equals to 4 and x is equals to 0. So that's how your graph behaves. Now that we have everything, how do we now graph this function? So the way you're going to graph this one, okay, simply like that. So how are we going to do that? So we're going to say we've got a point 0, 0. That's where the graph is going to cut the y-axis. Then we've got the turning point. The turning point is 2, negative 4. Okay, let's say our 2 is here. Let's say our negative 4 is there. So it will be this point. Okay. Then we've got x is equals to 0. Okay, x is equals to 0 is this point. Okay. Then another point we've got x is equals to 4. Okay, x is equals to 4. Let's say 4 is there. Okay, so therefore your graph in this case, it will come from this side and it will pass like that. Okay, so this is how you are going to graph this one. Okay, now let's talk about the common combinations that you are going to have on this topic. Let's say they're giving you the graph of f of x is equals to x squared. Now how are we going to graph this one? So the graph for this one, the way it's just going to be is you're just going to, okay, let me just draw one. Okay, so how is it going to be? So the graph of x squared, because whether I put a negative 1 or a 1, they'll be giving you one same y value. Okay, if I say 1 here, so it will just be this way and that way. So how is the graph going to be? The graph of x squared, it will go in this direction and it will go in that direction. Okay, now before I go any further, let me make something clear. When your value of a is less than 0, you have a maximum. Okay, then when your value of a is greater than 0, you have a minimum. The turning point, okay, or where your graph is going to start from. Okay, like in our case, in this case we have a minimum. Okay, a minimum. Why? Because the value of a is greater than 0. How? Let's look at the coefficient of a here. The coefficient of a here is 1. 1 is greater than 0, so we have a minimum like that. Very, very important to mention. Okay, then other things that you need to understand. Let's say you're asked to find the graph of let's say the graph of they're asking you to find the graph of f of x. Let me say f of x is equals to, let's say, negative x squared. Now this is a negative, so because it's negative, it's going to go to the negative values of x. Why? Because you said your a is negative, this value is less than 0. So because your value of a is less than 0, you're going to have a maximum. Okay, you are going to have a maximum point. So that's how you're going to graph that one. Let's say you're given another scenario where you're saying f of x is equals to, let me say, x plus 2, x squared plus 2. Now x squared plus 2, what this shows you is just that the 2 in this case is a shift in the y, then everything is the same. So your graph has shifted by 2 units. So let's say our 2 is there. So the graph, the way to just go the way x squared goes, it has just been changed by 2 units. That's how you're going to graph that one. Let's put another scenario. Let's say you have let me say x squared. Let me say x squared minus 3. When you say x squared minus 3, it just means that your graph has shifted to the negative y values by 3. Okay, so by negative, so this would be negative 3. This is our graph. Then we look at the value of x. It is a positive number. Okay, because it's a positive number, what are you going to have? You have a minimum point. So it is going to go like that, and it's going to go like that. Okay, now what this means, you're going to find the x where it's cutting the x axis. Okay, where now you're going to put the value of y to be 0. Then you solve to find those points. Another scenario that you can you need to understand on these functions is let's say you're given let me say you're given f of x. F of x is equals to, let's put the last one, let's say negative x plus 2 squared. Now how are you going to solve that? The one that is in the bracket shows you the shift in the x direction. Okay, so it just shows you that the x, so you're going to get this one and equate it to 0. So you're going to say x plus 2 is equals to 0. So x is equals to negative 2. What this means is that your graph has shifted in the x direction by 2 units. So it's going to start from there. Now in which direction is it going to go? You look at the symbol of the whole function. The symbol here is a negative, right? So it's going to the negative direction. So it's going to go this way and that way. Now you have to find that point. This is the y-intercept. On the y-intercept, x is equals to 0. So you just replace in the equation and you find that. Very, very important. Let's make it interesting. What if we say we put a constant? Let me say I put a constant here and I make it positive. Okay, so we have a shift of 2 units in the x direction. We also have a shift in the y direction of 2 units. So how are we going to solve that one? So you realize that because we've shifted 2 units in the y, so let's say our 2 is here and we've shifted negative 2. We've shifted by negative 2. Let's say our negative 2 is here. Okay, because you said you have to equate what is in the bracket. So x plus 2 should be equals to 0. So x is equals to negative 2. So this is a shift in the y, and this is the shift in the, this is the shift in the x, and this is the shift in the y. So that's your turning point. Okay, like I earlier said. So it's going, the graph is going to start from here. Then you look at the sign of the whole function. The sign of the whole function is what? It is positive. So because it is positive, it's going to go up. Okay, like that, and it's going to cut there. Now when it cuts here, this is the y-intercept. On the y-intercept, x is equals to 0, so you just replace 0 in there. Wherever there is x, replace 0. Then you find the point at that point. Okay, very, very important. Then let's talk about something very critical. rational functions. Okay, now when you're talking about rational functions, you are talking about a function that is in the form of a fraction. Okay, a fraction. Okay, so now on rational functions, you have to know how to solve rational equations, rational inequalities, rational, how do you sketch them. Very, very important. Okay, let me say if we are given, let's say 2 over x, let's say it is equals to 4 over, let me say, x plus 1. So how are you going to find that one? So this doesn't really require a lot. You're just going to cross multiply. Okay, you're just going to cross multiply and you solve and you find the value of x. So in this case, we're going to have what? You're going to have 2x. When I multiply 2 with what is down, what I'm going to have 2x plus 2. Then when I multiply x and 4, I'm going to have 4x. Okay, 4x. Then when I put like terms together, so I'll have 2 is equals to 4x. When I get the 2 to the other side, it becomes negative 2x. So 2 is equals to 4 minus 2x, that is just a 2x. I'm going to divide by 2 on both sides. So our x in that case will just be 1, like that. So a lot is not involved when you're finding rational functions. Okay, so those are just the basics. In your tutorial sheet, that is not there. Okay, because they know it's just simple arithmetic, nothing much. However, here I want to concentrate where it's very, very important. Rational inequalities. You have to know how to find rational inequalities. Let's say you're given 2 over, let's say, x minus 1. This, they've said, let me say 1 over, let me say 1 over x plus 1. Let's say this is greater than 2 over 3 minus x. Okay, so for rational inequalities, they are, however, different from the the rational equations where I just cross multiply. Here it's very wrong for you to cross multiply. Okay, so what you're just going to do is you take this one to the other side. Okay, then you solve. So you have 1 over x plus 1 minus 2 over 3 minus x. Note, I've just changed the sign of the negative to the numerator. Just always change the numerator. Okay, don't change the signs of what is down. Okay, the denominator. We're saying this is greater than 0, like that. Then what you're going to do is you're going to solve this like you solve any normal fraction. Okay, when you solve that, what am I going to get? I'm going to get 1 minus 3x. I'll merge the fractions. I'm going down. I have x plus 1. Then I have 3 minus x. I'm not solving everything because we've done this and all the videos are there on the drive and on YouTube. Okay, so we're saying this is greater than or equal to 0. Then what are you going to do? You're going to equate all your expressions to 0. Then you find the values of x at those points. Okay, so what are you going to have? You're saying 1 minus 3x. This is equals to 0. When I solve that, I'm getting what? I'm going to get negative 3x is equals to 1. Therefore x will just be equals to 1. It's equals to negative 1. So therefore negative 1. So our x will just be negative 1. It's going to be positive 1 over 3. So to just be a quarter, like that. It's going to be 1/3, like that. Okay, so 1/3. Then we've got x plus 1. You also equate this one to 0, so your x in this case will just be negative 1. You also have 3 minus x is equals to 0, so you're going to say your x in this case will just be 3. Okay, so these are the values of x that you have. So you now, after you get these values of x, you come up with a table of values. Okay, because you have to test your answers. We've got x is equals to 1 over 3. We've got x is equals to -1. We've got x is equals to, we had a 3. Okay, now what you're going to do, you're going to come up with let me say some form of a specialized number line. Okay, I'll call it specialized because it's not like the number line that you guys are familiar with. Okay, so this, let me say, because we've got 3 values, I'll also put 3 here. Okay, like that. Then I'll put this. Then what am I now going to have? What I'm going to have then is, let's say this is so I'll arrange them in from the smallest to the largest. So our smallest value of x that we have is -1. Then we've got 1 over 3. Then we've got a 3. Now what do we now have? Which equations gave us these answers? Okay, so the equations that gave us these answers, we had a 1 minus 3x. Okay, so I'll close there. We had an x plus 1. I'll close there. We also had a 3 minus x. I'll close there. Now what were these ones doing? These ones were multiplying and they were dividing by what is on the top. Okay, so let me just call this one will be the quotient. Okay, the answers that we're going to find should be the quotient. So now how are you now going to solve that one? So the way we solve these ones, like we earlier solved, so what do? You have to make sure that these ones are called the demarcations of signs. Okay, they will help you determine where the signs are going to fall. Okay, so very, very important. So if we solve, let's start, which equation gave us x is equals to -1? It is this one. Okay, so now if you get any value that is greater than -1, let me say a 0, and then you put in the equation, you're going to have positive numbers, right? So you have positive, positive, positive. But if you get any number that is less than -1, let's say a -2, you have a negative here. Okay, then let's come to which equation gave us 1 over 3? Is that one. So even that one, if you get any number that is greater than 1 over 3, let me say a 1. If we put a 1 in that equation, what are we going to have? We're going to have a negative number here. But if you put any number that is again greater than 1, let's say a 4 there, we're still going to have a negative. But if you put any number that is less than 1 over 3, let me say a 0 in that regard, I'm going to have a positive number. If I put another negative number, any number that is less than -1, I'm going to have a positive here. Okay, so that's what is there. Okay, then this here we didn't which one did we, this one, x plus 1, we said it was -1. Okay, if you get any number that is less than -1 and you put it there, let's say a -2, it will give us a negative number. Okay, so this is also a negative here. Now let's look at the last one, 3 and 3 minus x. Okay, so if you get any number that is greater than 3, we put it in that equation. What are we going to have? We're going to have a negative number. But if you put any number that is less than 3, let's say 1, we're going to have a positive number, a positive, a positive. Then what are you going to do? You're going to divide these signs or multiply them actually. So you know that a positive, a negative, a positive will just give you a negative. Okay, so this will be a negative. A positive, positive throughout, this will be a positive. This will give you a negative. This will give you a positive. Okay, now what values do you want? You want values that are greater than 0. Okay, greater than 0. So values that are greater than 0 are positive numbers, right? But now they haven't specified that it's equal to, because it's not equal to, so meaning those values will not be included. So let's put those ones. So what are you going to have? So positive values will from here. So because it's not equal to. So you're going to have open circles, okay? You only want positive numbers. Oh, this is also positive. So you only want positive numbers. Those are the values that are greater than 0. So therefore your solution set in this case will be your solution set in this case is it's going to be you want all the values from -1. -1 is not included, and you're going to end at 1/3. 1/3 is not included. Union, you're getting 3, and you're going all the way to positive infinity like that. So you have to know this one, very, very important. Then how do you sketch? How do you sketch rational functions? Okay, so let me make something clear. Let's say you're given f of x is equals to -2 over, let me say, x squared minus 4. Now, when you are sketching rational functions, make sure that the denominator, you have to find what we call the vertical asymptote and the horizontal asymptotes, okay? Now, when you're finding your vertical asymptote, get the denominator and equate it to 0. So what are you going to have? You're going to say x squared minus 4, this should be equals to 0, okay? So in that regard, it will be x squared minus 2 squared is equals to 0. This becomes the difference of 2 squares, okay? So it will be x minus 2 squared is equals to 0. So we have x minus 2, x plus 2 is equals to 0. So therefore, the values of x will be equals to 2, or x will be equals to negative 2. So those are the vertical asymptote. Your graph is not supposed to touch these x values, okay? Very, very important. You have to know that. Then when you're finding your horizontal asymptote, this relates to the y. Now here, that's where it's very tricky. If your denominator, if the power of x in the denominator is greater than the power of x in the numerator, your horizontal asymptote will be at y is equals to 0. Y is equals to 0. This is the x-axis, okay? Very important for you to know. So what you're going to do is what? When you're drawing your graph, let me say this is the y-axis, this is the x-axis. Put your horizontal asymptotes, okay, where it's not going to touch the graph, okay? So let's say this is -2, and the other value that we found, it was 2, okay? So you are going to come up with a table of values for this x plus 1 and x minus 2, okay? Like we did earlier, you come up with a table of values, and the signs that you are going to get, that's what will determine the way the graph will move, okay? The way the graph will move. So if, let's say, I had positive, because let me say if I had positive, let me say this is this was -2, and this was 2. Then the values that we had, let me say this side, after solving, this side had the positive, on the middle had the negative, and on the far end had the positive. So these are the regions on the graph, just the way you're going to find your answers. So now, what does that mean? You start with this region, and this is positive, but look at the value of y on top. Look at the value that is on top, that is a negative. So you're going to be dividing by this. But if it was a positive, if, let me say, on top I only had the positive 2 like that, we're just going to follow this one. It will just go in the positive direction, but it will not touch the asymptote. But we have a negative. Because we have a negative, we're going to divide this, because this is a ration, we're dividing, these are fractions, we're going to divide by that negative, and you are going to get a negative. Therefore, your graph is going to go down like that, okay? Then when you come in the middle, you have a negative and you have a negative. They'll give you a positive, okay? A positive. So what I'm going to do, in the positive values like that. Don't touch the asymptotes. Then you come to the last one. This is positive, there's a negative on top, so you're going to go to the negative values. Okay, very, very important. So this is how you're going to graph this one. Okay, then one thing that I should also mention here is, if let me say you're given okay, our graph has gone. Okay, let's say you had a scenario where you have what did I want to say? Okay, so from the graph that we had, you're able to find the domain and the range. Okay, actually it's even simpler. Okay, I've lost my graph, but you had to show that it began from negative infinity, it went all the way to negative 2. Negative 2 was a vertical asymptote, so you are not going to touch it. We only want the values of x, right, in the domain, so negative 2 is not included. Then we went to another range where we went at negative 2 to 2. Okay, these ones are not included, they are asymptotes. Then we move from 2 to all the way to positive infinity. Then the range, these are the values of y. If you saw our graph, it was something like that. Let me say these are our asymptote. The range, it had to move like that. Okay, these are the values of y. Okay, this is the horizontal asymptote. Okay, so the lowest value that you can have for y, these are starting from negative infinity, they are going all the way to positive infinity. But in that graph we had this point, so this was a turning point. So the way we're going to represent the range to be negative infinity to 0, union, the turning point that you're going to have, comma, you're going all the way to positive infinity. It's very easier to find the domain and the range from a graph, because it's straightforward. So you have to understand those. Very, very important. Okay, very, very important. Then let's talk about what we call radical functions. Now a radical function is one that is in the root. Okay, one that is in the root is called a radical function, a function with a root. So let me say f of x is equals to, let me say, the square root of x. Okay, this is a radical function, so you have to know that. Okay, so now here you have to know how to solve radical equations, how to also solve radical inequalities. I've shown how you find inequalities. Okay, at least I've done a good one on that one. I've done justice on that one. You have to know how to find radical equations. Okay, in your tutorial sheet 4 you've got a radical inequality. So I'm going to solve, let's say you're given let's say you're given the square root of x is equals to 1. Okay, just as a simpler one. So what I'm going to do is just square on both sides so that you remove the root. So you square that. Okay, so when you square that, the square and the root will cancel, so you have x is equals to 1 squared is just 1. So 1 squared is just 1. So that will be your answer. Then you have to check if this one is an answer or if it's a solution. So if I say the square root of 1, is it really equals to 1? So you're able to see that 1 is equals to 1. So because it's that, so it means that that is a solution. Okay, so that's how we solve radical equations. Okay, as simple as they may look, sometimes they might complicate them, but just know. Okay, if I say the square root of x minus 1 is equals to 3, so what am I going to do? I'm just going to square on both sides. Okay, so the square and the root will cancel, so you have x minus 1 is equals to 3 squared, that is just a 9. Okay, so x is just equals to 9 plus 1. X is equals to 10. So you have to check this solution. You're going to say the square root of x is 10, so 10 minus 1 is equals to 3. So 10 minus 1, that is a 9, so the square root of 9 is equals to 3. So the square root of 9 is positive or minus 3 is equals to 3. Okay, so in this case, what do you want? You only want 3, right? The negative one, you're not going to get it because it will not be a solution. Why? Because you don't want a negative number, okay? So what are you going to have? You only have your solution set to just be a 3, not a negative, because the square root of 9 is positive or minus. So this is how you solve radical functions. Then how do you graph them? Okay, that's what I want to talk about. How do you now graph these ones? Okay, so I'll represent this in form of a graph. I think it will be so effective. Now this one I'm going to give you, it will serve you a lot because it's more simplified. Okay, let me say this is my y-axis, this is my x-axis. So if you don't understand this, you can still access all the videos both on the drive and on YouTube. Okay, so what are you going to do? So for a radical function, so how are you going to represent it? The square root of x, the graph of the square root of x, it just moves like that. This is a graph of f of x is equals to the root of x. Okay, you have to understand that one. Then if it's negative, what does it mean? It just be on the other side, right? So it will be like that. Okay, it's the same as the one I've drawn, but not really like drawn to scale. So what are you going to have? You're going to have the same graph, but like that. So this is a graph of, you know, the square root of negative x. Okay, because we're going to the negative. So this is negative x. Then when you come down, what if your graph is like that? Because it's like that. So this is negative the square root of negative x. Then if your graph goes like that, so what is this going to be? The graph will just be negative square root of x. Okay, now let me make something very clear. What pattern are you able to see? The value of x here is what? Is positive. The value of y is what? Is also positive. Look at how the graph is going in the positive direction. Let's look at the other one. The value of y in this region is what? It is positive. Okay, the value of x in this region is what? It is negative. Look at where it's going, right? Going to the negative values of x. Let's come to this one. The value of x and the y, both of them are negative. The values of x here, they are positive. The values of x here, of y, they are what? They are negative. Okay, so that's how they're going to be. Now let me make something very clear here. You have to make sure that because we're talking about the values of y, so when we're talking about the values of y in this region, okay, because it's positive, it will be going up. Your graph will be going up. Then look at the value of x. The value of x, we are saying it is positive. Because it's positive, it's going to go to the x values. So that's how our graph is going to be. Then let's come to the next side. The value of x, y, we have said it's what? It is a positive. Because it's positive, it's going to be going up. Now the values of x is a negative. Because it's a negative, your graph is going to be going to what? Negative values of x. Okay, let's come down. Both of them, y is negative. Because your y is negative, the graph is going to be going what? Down. Okay, then your x in this region is what? It is also negative. Because it's negative, it's going to your graph is going to be going to the negative values of x. That's how it's like that. Then let's come to this one. You're able to see that the values of y in this case they're going to it's negative. Okay, because it's negative, your graph is going to be going down. The value of y, the value of x in this case, they are positive. Because they are positive, you're going to be going to the positive values of x. That's how these symbols are shown. Now if you know this, you are good. Why am I saying you're good? Because what you're just going to be having now are shifts. Okay, shift, a turning point where just the graph starts from. That's all. Okay, where just the graph starts from. Let's say if you are given to say the way it is, like the square root of x minus, let's say minus 4. Let me put a different color just for shift. Let me use different color. Let's say minus 4. Because it's a minus 4, this just shows you that this is a shift in the x, and when it's the shift in the x, what did it do? You get what is in the root and equate it to 0, so therefore your x will just be equals to a 4, right? When you take the 4 to the other side, if x is going to be equals to 4, it means your graph is going to start at 4. Let's say 4 is here. So how is it going to go? Because everything is positive, your x is positive, even the value of just the function is positive, because both of them are positive. So how is your graph going to go? It's going to go in this direction, okay? Going to just the same like that, okay? So that's how we're going to do it. That's just the shift. Let's say now you have another scenario. Let's say instead of negative 4 or negative or positive 4, so if it is positive 4, if it's positive 4, because it's positive 4, you're going to equate it to 0, so x will be equals to negative 4, right? So negative 4 be here. Then because everything is positive, your y is positive and your x is positive, you are still going to the positive direction. So it's just going to go the same way as that graph, the same way as this graph, in that direction. But now it's going to have cut, it might have cut the y-axis at that point. So you have to find the point at that, and at the y-axis you know that x is equals to 0. So just replace 0 where there's x in the equation, and you find like that. Let's say you have another shift, okay? So these are just shifts. Everything we've talked about will be just the same, okay? Let's say let me put a negative here. I also put, let me put a 3. So a 3 is just a shift, because let me put a negative. Let me say a negative 3. A 3 is a shift in the x, so this will just be positive 3. Like if we equate that to 0, so to be positive 3, so I'm saying this is 3. Then you're able to see that the value of the function is negative, okay, and the value of x is positive. So what are you going to do? Okay, what are you going to do? So it's going to start at 3, because the value of the function is negative, so it's going to go to the negative direction, but where? To the positive values of x. So that's how it's going to go, okay? So that's how you just deal with these shifts. So whatever scenario they give you, just know this diagram, then you're good to go, okay? Very, very important for you to know that aspect. So that's how you graph those ones. Very simple and very straightforward. Now let's talk about something else. Let's talk about modulus functions. Now this is very, very interesting. Okay, so when I'm talking about modulus function, so a modulus function returns the magnitude of a given number regardless of its sign. Okay, that you are supposed to know. So if we say the modulus of x, so even on this topic, you have to also know how to find the, equations, of a modulus. So let me start with the equations before I start graphing. So if I say the modulus of x is equals to, let me say 1. So how are you going to find this one? You're going to say x is equals to, because you've removed the modulus function or the absolute value function, so you're going to say positive or minus 1. That would be your answer. So if I say again, if they give you, let me say x plus 1, this is in a modulus, is equals to, let me say 3. So what are you going to do? Remove the modulus. So to be x plus 1 will be, the first answer you're going to have, it is x is equals to 3. Then the other one will be x plus 1 is equals to negative 3. Then solve the two equations. So you're going to have x is equals to 3 minus 1, x is equals to 2. Then when we solve the one that is down, to be x is equals to negative 3 minus 1, so x is equals to negative 4. You will have two values of x. Then what are you going to have? again, test your solutions. Okay, test your solutions. Okay, so you test your solutions where you get the 2, you put it here where there is x, you put it here. If you say 2 plus 1, is it going to give you 3? And the modulus of that is 3? Yes, it is going to be correct. Now let's also look at the other one. We find that x is equals to 4. If I put 4 here, 4 plus 1, is 4 plus 1, that is a 5. The modulus of 5 is just 5. Is it equals to 3? No. So 4 is not a solution. Okay, so the only answer here is 2. So that's how you find modulus equations. Very, very simple and very straightforward. That's what is in your tutorial sheet 4. All those equations, just that's what you are going to do, nothing much. Very simple and very straightforward. Now let me talk about what I wanted to talk about. So if you're given the modulus, let me say, of x, the answer will just be x. So when you're given the modulus of 2, the answer will just be a 2. When you're given the modulus of -2, the answer will just be a 2. Now what are we talking about? Whether it's a negative or a positive, a modulus or the absolute value function will still give you a positive number. Okay, now let me make it a bit complicated. Let's simplify this one. Let's say -3 minus 4. What are you going to have? So you solve what is in the modulus. Then -3 minus 4, that is just a -7. The modulus of whether it's a negative or a positive number, you're just still going to get a positive number. So that's how you solve that one. Okay, maybe let's also solve the last one to just make it interesting. Let's say you have the they ask you to find the modulus of, let me say, -2 modulus 3 minus 4 modulus minus 1. Then you solve that one. How are you going to solve one? So write your -2. Okay, find the modulus of what of this. Okay, so what is 3 minus 1? That 3 minus 4, that is a -1. The modulus of a 1 or a -1, it just be 1, right? So you have +1 minus +1 minus 1. Okay, so how are you now going to solve that one? So you solve what is in the bracket. -2 plus 1, that is a -1. -1 minus 1, that is a 0. The modulus of a 0, that is just still a 0. Okay, so that's how you solve those ones. Now how do you now graph modulus functions? Okay, so let's graph modulus functions. Okay, very simple. It's one of the interesting topics, very straight to the point. Okay, so the modulus, let me say f of x. Let's say f of x is equals to, you sketch, the modulus of x. So this is straightforward and simple. Let's say this is x, and this is the y-axis, this is the x-axis. Okay, so in this case, if we're going to draw a table of values x and y, let's say this is our table of values. Okay, let's put numbers like from 1, 0 and -1. So let's be replacing these values in the modulus. So if we say the modulus of 1, if we put it there, what are you going to have? It's just a 1, right? The modulus of 0 to be a 0, the modulus of -1 it to be 1. So what you're going to realize is you're just going to have positive numbers throughout. Okay, so all the values that you're going to get, only positive values. So the modulus there, if we were to graph this one, if this is 1, this is -1, this is 0, and this is 1. 1, 1 is that point. Okay, 0, 0 is that point. -1, 1 is that point. Then you join this one. It will just be straight lines. Okay, so this is how you graph this one. So whatever the function they give you, as long as you know this, you are good to go. Okay, now another thing that you need to understand, always look at the value of the function and the sign of the function itself and the values of x. Everything they'll give you will just be shifts. Okay, if you are able to see that this is positive, right, so it's going to go positive. You're able to see that this one is also positive, it's going to the positive values of x. Okay, so that is very important. Now let's include shifts in this modulus function. Let's say you have allow me to rub this. Let's say you have let's include the shift in the x. So when you include the shift, get what is in the bracket equated to 0, it just be 2. Okay, so you have a 2 here. What this means is that it's going to go like that and it's going to go like that. You just shifted 2 units, then you find this point. That's how you're going to solve that one. Very simple and very straightforward. So that's a shift in the x. Okay, then let's say you've got this. Let's say you have a 3 here, and we also put, let's change the value of the function to be negative. Now if it's negative, what are you going to have? You're able to see that this is a shift in the y. In the x there is no shift. So because in the x there is no shift, let's shift to y. So y shift of 3, so the 3 will be here. Okay, this will be 3. Now which direction are we going to go? We're going to because the function itself is negative, so we're going to the negative values. Okay, so the negative values. So how is it going to move? It's going to go in this direction and in that direction. Now you're able to see that it cuts the x-axis and into 2 directions. So you find those ones by equating the function to be 0. Okay, so that's how you are going to solve that one. So whatever they'll be giving you will just be shifts. So when you're good on that one, then you are fine. Okay, now let's talk about piecewise functions. Now a piecewise function is just a function that is defined by a function that is defined by having multiple sub functions. Okay, so this function has more than one function. That's what I was saying. But now these two must more function. Let's say you're given f of x is equals to, let's say you're given x plus 2, you've got 1, you've got x squared. Then they'll give you the domain for these functions. They might give you x values are greater than, are less than or equal to -1. They might give you x is in between -1, x like that. Maybe they might also give you x is greater than or equal to 1. So these are very simple to solve because they've already given you the domain. Okay, so how are you going to graph it? Like for the first equation, let's come up with a table of values. Very simple as well. So let's say you have x, you've got y, right? So because we want all the values of x that are less than -1. Okay, so we're going to be placing in the equation that they've given us. Okay, so what are you going to have? Let's start from, because it's less than or equal to -1. Let's start from -1 itself, -2, -3. If we put -1 in this equation, okay, -1 plus 2, what are you going to have? You're just going to have a 1. So this will be a 1. Then the other one will be what? When you put -2 in the function, what are we going to have? You realize that you're going to have a 0. Then if you put -3 there, we're going to have a -1. So this is the one of the functions that you're going to graph. Okay, then let's graph the second one. Okay, so let me just put these values in advance, then we'll graph them all together. Okay, then we've got x is between -1 and 1. Okay, this is the domain. So just put those ones, nothing much. So you put -1, 0 and 1. Those are the values of x that you have. Okay, so now what values of y are going to have? They've already given you that all of them, they are going to give you 1. So all of them will be 1, 1, 1. Okay, let's come to the next one, the last one. Okay, the last one is x squared. Okay, x squared. they are saying x is greater than or equal to 1. So you want all the values that are greater than or equal to 1. So you start from 1 itself. Other values that are greater than 1, you can say 2, you can say 3, 4, 5. I'm just going to get 3. Allow me to get 3. Then what are you going to do? 1 squared is what? Is 1. 2 squared is what? Is 4. 3 squared is what? Is 9. Then when you have these values, what are you going to do? You graph them, okay? You just graph them on one graph, okay? That's what we call a piecewise function. Okay, so let's say this is our graph. Okay, like that. So let's start with this first one. You know, you've got -1, 1. Let me say this is -1. You've got a 1 here. So this is 1, okay? So I'm going to shade it because it's greater than or equal to 1, okay? So 1 is included. Then you've got -2, 0. -2, 0 will just be -2, 0. Okay. So this is 1. Let me say this is let me say -2. -2. Let me say -2 is here. So -2, 0 will just be that point. Then -3, -1. Let me say -3 is there. It's here. Okay. -3 is there. So what are you going? -3, -1. Let me say it's just somewhere here. Let me say somewhere here. Our -1 is there. So our graph will be like a straight line. So to go something like that. Okay. This is the first graph, not really drawn to scale. Then you draw the second one as well. Okay. You've got -1, 1. -1, 1 is this point. But now because it's only in between, you are not including these values because look at the inequality. So you're not including them. So you're going to put circles. Then you've got 0, 1. 0, 1 will just be this point, okay? This point. Then you have 1, 1. Let's say this is 1. 1, 1 will be that point. So there are circles like that. Then you join them like that, okay? So let me just draw it nicely. Okay. So the first points that we have, you're going to join them from here to that point, okay? Then the next points that we are having, you've seen them, they are going in this direction, okay? Just to put them nicely like that. So let's say this is the 1, 1, the last point that we had, this one. So it's there. Then we said these ones are not included, okay? Then the last graph, we've got 1, 1, which is this same point, okay? Now is this one included? Yes, it's included on this graph. So what you're going to do, you're going to shade, okay? So you shade this. Then what other point do you have? We've got 2, 4. Let's say 2 is there. Our 4, let's say, is somewhere there. Let's say 4 is somewhere there. So it will be a point somewhere there. Then we've got 3, 9. Let's say 3 is here. Our 9 is somewhere there. Let's say 9 is there. So it means your graph, where is it going? It's going in that direction, okay? So this would be the graph, and you would have solved the piecewise function. Very, very important. Now let's talk about the last part that you need to understand. Polynomials. Okay. Now I'll not spend a lot of time on polynomials. On polynomials, you have to understand, you have to know how to factorize polynomials, okay? You have to know how to find the remainder and factor theorem. Very, very important. You have to know how to, solve using synthetic division. Okay, then you have to know how to, solve using long division from primary. Even here it's there. It's the same concept. You have to know how to find equations and inequalities. Okay, that is very important for you to know. Okay, so when you know these ones, you are good. Okay, so the general form that you should always achieve, okay, the general form that you should always achieve is f of x, which is the function of the polynomial that they've given you, then the factor, let's say a factor in this case, or the divisor is x minus 1, is equals to the quotient. The quotient is the number that you get after dividing, plus the remainder that you're going to get if at all you have a remainder. Okay, x minus 1, the divisor. Okay, always know this. When you know this one, you're good. So now how do you find the remainder? Let's say let me say you're given p of x, a polynomial is just it's raised to the power 3 going up. Okay, plus 2x squared plus 4x plus 10. What I'm going to mention here is that you have to make sure that every time the values of x are decreasing. The values of x, I mean these ones, are decreasing. If it's x to the power 4, it's the next one will be x to the power 3. But now it's x to the power 3, the next one will be x to the power 2. Always make sure that you're dividing. Otherwise, that's what they're going to test you on. Okay. Then maybe let's say I'm going to find the remainder. Let's say x, you're dividing this by x minus 1. So if you only want to find the remainder, because the remainder is just it's limited, you're going to equate this to 0. So what are you going to have as your x? So your x in this case will just be equals to a 1. Okay, so the remainder therefore just be equals to wherever there is x, because we've said x equals to 1, you're going to be replacing wherever there is x, you're going to be replacing by 1. So 1 to the power 3 plus 2 1 squared plus 4 1 plus 10. Okay, so your r in that case will just be 1 plus 1 2 1 squared is just the 2, it's just the 1 multiplied by 2 is just the 2 plus 4 plus 10. So the remainder will just be equals to 1 plus 2, that is just a 3 plus that's, so you're going to have a 17. So how are you going to represent it? You write your polynomial x to the power 3 plus 2x so how are you going to represent it? So you write your polynomial, which is x to the power 3 plus 2x squared plus 4x plus 10, everything over what was your divisor? Your divisor was x minus 1. Okay, this, what did it give you as your quotient? You don't know your quotient, because I've said the remainder, I can only find the remainder. Okay, plus what remainder did you find? It's 17 over what were you dividing? Your divisor, x minus 1. Now how are you going to find the quotient? That's where now long division comes in. Okay, that's where now long division comes in. Okay, that's where now long division comes in. For the remainder, you are only going to find the remainder. Okay, so now if you're going to find if you're going to use long division, you can either use long division or what we call synthetic division. Now I'm not going to spend a lot of time, because we've already done videos on these ones. Okay, I don't want to keep you for long. So what are you now going to have? You have x to the power 3, okay, plus 2x squared plus 4x plus 10. So this is long division. Okay, so you always divide with the value of x, the highest value of x. If you had the x squared, you're dividing by x squared, but now you have x, so we're just going to be dividing. So we're going to divide by x, so x divided into this x to the power 3. So you have x to the power x squared, because 1x and 1x will cancel. Then this x multiplied by x, it just gives us x squared multiplied by x, that will just give us x to the power 3. Then this same x again will multiply by our negative 1 there. So you have negative x squared, okay, divided by. So what are you going to do now? You're going to subtract. So you're going to be subtracting this minus this. Then you find your answer. Then you're going to do this minus this. Okay, so let's start with the first one. So your x squared minus your x squared, that will just give you a 0. Okay, so this is just a 0. I'll not put it. Then you've got 2x squared minus x. Okay, so what are you going to have? So you know that your x and your x to just add, right? So you're going to have a 3x squared. Okay, then again you're going to divide this into that. So when you divide that, what are you going to have? You just have a plus 3x, okay, plus 3x, yeah, plus 3x, yes. Then again you're going to multiply this multiplied by those. So what are you going to have? You have 3x squared minus 3x. Then you drop the 4. Okay, so plus 4. Then you solve. Again you subtract the way we were doing. So this will give us 0. So I'm not going to write the 0. I'll write just for this one. Okay, so 4 minus 3x. Okay, that just gives me, is it? Oh, it's 4x actually. This is 4x. Okay, so 4x minus, so that just gives me a positive 7x. Okay, so you write it down, but allow me to write it here because of space. So I have a 7x. Okay, now this is a 7x. Now I'm going to divide by this x. Okay, when I divide into that, I'm just going to get a 7. Okay, I'm going to get a 7 multiplied by again this expression. When I do that, I'm going to have 7x minus 7. So then what happens? I'm going to drop the 10. Okay, when I drop the 10, it's positive 10. Okay, so again I subtract the 2. Okay, so this will give me a 0, so I'll not write that 0. Then your 10 minus your 7, that will just give us a negative 10. It will give us a 10 minus 7, that would just give us a 17. So now you can't divide x divided into 17 because you don't know what x is. So therefore this the one that we found here, this is what we call the quotient. Okay, the one on top. Then this is the divisor. Okay, then the 17 that we found is the remainder. Okay, so now you find the quotient to find the remainder. So that's how you find, wait, thank you. So that's how you're going to find using long division. Now let's talk about the last part. You can also find this using, the remainder theory, the synthetic division. Factor theorem, we're just talking about, a factor. If I say 8 divided by 2, that just gives me 4. Is there a remainder? No. If I say 8 divided by 3, what is the answer? It's 2. Remainder what? Remainder 2. Now, because it gives me a remainder, it is not a factor, right? So 3 is not a factor of 8. But in our case, for this one, 2 divided into 8, it's giving me 4. Is there a remainder? The remainder is 0. So there is no remainder. So because there's no remainder, 2 is a factor of 8. That's what the factor theorem is. So for the factor theorem, we mean when we get this x minus 1, when you divide it into this, and if it gives us, if it doesn't give us any remainder, like it gave us 17, then it is a factor. Okay, so to find that one, you're going to use trial and error. You're going to be trying numbers, yeah, like that. So now for synthetic division, let's talk about synthetic division. Okay, this is very simple as well. So we're saying x is equals to 1. So get all the coefficients of x in this expression. Okay, so we're going to start with 1, this is 2, this is 4, this is 10. Make sure that your powers are always decreasing. Let me say if they just gave us something like x to the power 3 plus 4x plus 10. Actually, that's what they'll give you most of the time. So make sure that when you're getting your power, your coefficients, you are going to get 1, yes, for x to the power 3. But now you're not just going to get the 4. You put the 0 because there's x squared that is invisible. Then now that's when you put the 4, then you're 10 like that. That's what I mean. Always the powers of x should be decreasing. It's just that in this example we've been given the arrangement is just fine. So how are we going to do? Put a 0 here, then add what is on top and what is down. You add that one, so that just gives us a 1. Then you multiply 1 multiplied by 1, then the answer that you're going to find, you put it there. So let's just do that. 1 multiplied by 1, that is 1. 2 plus 1, that is just a 2. That is just a 2. Okay, no, it's a 3 actually. What am I doing? Okay, 3. 1 multiplied by 3, that is a 3. 4 multiplied by 4 plus, that is a 7. 1 multiplied by 7, that is a 7. Then you close here. 10 plus 7, that is a 17. So what this tells you, that the 17 is the remainder. Okay, then these are the answer. So the answer, you drop the powers of x by 1. So what are you going to have? You have x squared plus 3x plus 7. So this is one of the factors, okay, but it's not really like a factor because there's a remainder. So if it was a factor, if you had a 0 here, what are you going to do? You have to simply, this just shows you that this is the what, the answer that we get, the quotient. Okay, that is a quotient. If you want to find other factors, let's say for the 0 here, and this was a quadratic, we solve that quadratic and we find those values of x. So this is how we solve polynomials, and that's where we're going to end from for today. Wish you well in probably in your next quiz and other things. Want another 100%. Thank you.